Here's sample test problem number 8 for sample test 2. Use Gauss's law to show that the electric field due to a non-conducting infinite plane with uniform charge per unit area sigma is given by electric field is equal to sigma over 2 epsilon naught. In other words, the electric field will be constant because sigma is a constant. Alright, well, we already have our Gaussian surface chosen for us. That's this cylinder here. So that is our Gaussian surface, and we have the E field going through the end caps of that surface, but not through the sides of that surface. So if we were to start from Gauss's law, we would say that over a closed surface, E dot dA through that closed surface is equal to the charge enclosed over epsilon naught. And we can break up this integral into two parts. Think of the E dot dA through the sides of that surface plus the integral of E dot dA through the end caps. And all that's equal to the charge enclosed over epsilon naught. Well, through the sides, we've got this situation where the E field is going in the x direction, the area vector is going out this way, and there's a 90-degree angle between the two, so E dot dA is going to be 0 due to that dot product, and so there's going to be no flux through the sides of this Gaussian surface, and there'll be no E field due to that. So we only have to worry about the E field going through the end caps. And through one end cap we have an E field in the parallel direction with the area vector, and through the other end cap we have an E field in a parallel direction with the area vector. So the flux through one end cap is EA, and the flux through the other end cap is EA. So our total flux is going to be 2 EA. And that's going to be equal to the charge enclosed divided by epsilon naught. What is the charge enclosed? That is the charge that is in this little disk right here that is enclosed by the Gaussian surface. That little disk has an area A, and it has a surface charge density sigma. So the charge enclosed is equal to the charge per area sigma times the area A. So what we have now is 2EA is equal to the charge enclosed, which is sigma times A over epsilon naught. So the A's on both sides of this equation will cancel out, and we are left with the fact that our E field equals sigma over 2 epsilon naught. And that is a constant E field everywhere we go on either side of this infinite plane, because it's constant everywhere, sigma over 2 epsilon naught. Sounds good. Here's part B. If E is equal to 2 times 10 to the 6 newtons per coulomb, and epsilon naught is 8.85 times 10 minus 12 coulombs squared per newton meter squared, what is sigma? Well, we can just rearrange this last equation, and we would say that sigma is equal to 2 epsilon naught times the E field. So that's going to be 2 times 8.85 times 10 to the minus 12 times the E field, which was given as 2 times 10 to the 6. And so this is equal to 3.54 times 10 to the minus 5 coulombs per meter squared. Everything's SI system, and the other units canceled. 3.54 times 10 to the minus 5 coulombs per meter squared is our charge per area for this plane of charge.